This video is on a method of solving quadratic equations called completing the square. So let me just show you an example of where it might be useful to use completing the square. So if we look at this first problem, it says, can you solve for x in x squared plus 6x plus 2 is equal to 0? So one thought might be, oh, well, maybe we can factor this and then use the zero product property. So when I go to try to set up for factoring, let's see what happens. So if I use my x, I need something that will multiply to 2 and add to be 6. So I know the only things that multiply to 2 are 2 times 1, but 2 plus 1 is 3. So nothing works here. So this is not factorable. So whenever we have a quadratic equation that's not factorable, and we can't use square roots here either because there's two terms that have x's. So we could use the quadratic formula, but sometimes the quadratic formula takes a really long time. So the other option would be to try completing the square. So here we can use completing the square. Okay, so I've kind of written the steps along the left-hand side of the page, and then I'm going to show the example along the right-hand side of the page, so you can set up your page to be the same. And then once you have it set up, you can start taking the notes. So the idea here is with x squared plus 6x plus 2 equal to 0, the first step when we're completing the square is going to be to get the constant by itself. So here our constant term is the plus 2. So to get rid of a plus 2, I'd subtract 2 from both sides. And that would give me x squared plus 6x is equal to negative 2. Okay, so now the next step is where we're doing what's called completing the square. And the idea here is, this is getting back to the idea of a perfect square trinomial. So if you would recall from Algebra 1, or even from geometry, a perfect square trinomial is x plus y parentheses squared is equal to x squared plus 2xy plus y squared. And the idea is we'd like to turn the left-hand side of this equation into a perfect square trinomial. So I'm thinking x squared plus 6x plus something I write right here. I'd like to have this left-hand side all work out to be a perfect square trinomial. And the key to doing this is to take the b value, that's 6. Ooh, excuse me. Didn't mean to make that blue line so thick. So to take the b value of 6, and the key is you do b divided by 2 and then square it. Because the idea is that's how we can get from like this middle term in this form to the y squared term. So in this problem, I would do 6 divided by 2 squared, which is 3 squared, which is 9. So that's telling me that in order to make this a perfect square trinomial, I need to add 9 right there. But by adding 9, I've actually changed this equation. So if I add 9 to the left side, I also need to add 9 to the right. And that's a really important step. So don't forget here that whatever you add to the one side, you need to add to the other side. So don't forget. Must add to both sides. Okay. So now we can combine the like terms on the right-hand side. So that leaves us with a new equation which looks like x squared plus 6x plus 9 is equal to negative 2 plus 9, which is 7. Okay, so I'm going to continue to work on this problem on the next page. Okay, so I'm just going to rewrite the problem one more time. So we had x squared plus 6x plus 9 is equal to 7. Okay, so now we are ready to factor. And what we're going to factor is actually the left-hand side of the equation. And it should be really easy to factor because we just designed it to be a perfect square trinomial. So we know perfect square trinomials are always factoring into, in this case it's going to be x plus 3 squared, because in that b spot we have a 6. So we would do 6 divided by 2 to get 3 in that spot, and that's how we'd know how to factor. If I haven't convinced you, you could also use the traditional x method of factoring. You say what multiplies to 9 and adds to 6, and it's 3 and 3, so then you know it's x plus 3 times x plus 3. But the trick is to do b divided by 2. So b divided by 2 will always be what goes in that spot. And then on the other side of the equation, I still have the equal to 7. Okay? So now, if I just rewrite that same line of the equation, x plus 3 squared is equal to 7. Now, this looks like a square roots problem. And I know how to solve a square roots problem. All I have to do is square root both sides to cancel out the squared. Then I have x plus 3 is equal to 7 isn't a perfect square, so I'll write plus or minus the square root of 7. Then I can subtract 3 from both sides. And I get x is equal to negative 3 plus or minus the square root of 7. And that could be my final answer, or I could use a calculator and get that in a decimal form, and I'd get two different answers, right? Because we have the plus or minus sign. Okay, so let's look at another example, and I'm not going to write out all the steps this time, so I'm going to go a little bit faster, but hopefully you'll get the hang of it. So the first step is to get the constant by itself. So I'm going to move that minus 2 by adding 2. Now we have x squared plus 8x is equal to 2. And I intentionally left this gap here because I know I'm going to add something in that spot, and I'm actually going to do that little plus something on the other side too, because I'm going to add this thing to both sides. And the way I figure out what I'm going to add is I'm going to do b, which is 8, divided by 2, and then square it. And in this case, that gives me 4 squared, which is 16. So that's telling me to add 16 to both sides of the equation. So now I have x squared plus 8x plus 16 is equal to 18. From there I can factor. So I'm factoring the left-hand side, and it's b divided by 2 to get the term for the factor. So it's going to be x plus 8 divided by 2, 4, squared is equal to 18. From here, I can solve using square roots, so I square root both sides. Cancels out the squared. I get x plus 4 is equal to the square root of 18, and don't forget the plus or minus. Then I would subtract 4 from both sides and get x equals negative 4 plus or minus the square root of 18. And that would be my final answer. Or again, I could plug that into my calculator and get a decimal answer. Alright, so we have one last example, and I'm going to start you off on this example, but then I'm actually going to have you guys finish it on your own. So this one is a little bit different because if you notice, A is not 1 here. A is 6, right? So whenever A is not 1, you have to do something a little bit different at the beginning. And the idea is this process of completing the square only works when A is 1. So in order to get A equal to 1, we could just divide every term by A at the beginning of the process. So because this is 6, I'm dividing by 6. And that's going to cancel there. So I'll have x squared, 48 divided by 6 is 8. So I have an 8 here is equal to negative 2x. Okay, now this is back to being like a normal problem. So remember, the first step in a normal problem is to get the constant by itself. Well, my constant is this 8x, so I like to add that over to the other side, which would give me x squared is equal to negative 2x plus 8. And now I'm going to add 2x over to the left, and I have x squared plus 2x plus something is equal to 8 plus something. So I'm going to leave the rest up to you. So can you complete the square, factor, and solve using square roots to get a final answer here?